Got a nice easy question to get started with. It's easy as long as we spot that the question's about power. It doesn't mention the word power, but it does give the number of watts for each bulb. So that, the fact it's watts tells us it's power. So a nice easy equation. P equals V times I. We know the power, we know the voltage, we're trying to find the current. Rearrange. I equals P over V, which for bulb X is 24 divided by 12, which is 2.0 amps. Similarly for the other bulb, bulb Y, I'm not even going to bother writing the original equation. I equals P over V, which is 18 divided by 6, which is 3.0 amps. 1 mark for each, dead easy. Next part of the question, bulb X is connected in a circuit and operates at its normal brightness for 2 hours. Well, to meet its normal brightness, it must be connected to its normal voltage and using its normal current. So in other words, we know that it's connected to a 24 volt supply, which means it will be using a current of 2 amps. And the power it's using will be 24 watts. So for the first part, how much energy? We know the power, we know the time, so energy is power times time. 24 times, it's 2 hours. Of course, we have to put that in seconds. So 2 times 60 to convert to minutes, times 60 again to convert to seconds. Don't forget my calculator. 24 times 2 times 60 times 60. Calculator says 172800. Should put that in standard form really. 1, 2, 3, 4, 5, 1.73 times 10 to the 5 joules. How much charge? Well, we know about current, we know about time, we ask for charge. So it's current equals the charge moving divided by the time, which we can rearrange. So delta Q, the amount of charge that flows, equals I times delta T, which is 2 amps times the time, again is 2 hours, times 60 times 60, and get the calculator. 2 times 2 times 60 times 60, 14,400, which, put it in standard form, 1.44 times 10 to the 4, and of course I've been finding the charge, it's got units of coulombs. So there's the first question, 4 marks available. For question 2, it tells us that the battery voltage is 9 volts. It says this resistance is 120 ohms and R2 is 60 ohms. Calculate the current flowing in the circuit. Well, dead straightforward. Got 2 resistors here connected in series. Although the voltmeter is there measuring, it doesn't actually change the circuit, it just measures what's there. So 60 ohms and 120 ohms is obviously a total resistance of 60 plus 120, 180 ohms. So then to find the current in the circuit, we know the voltage, I, so the current is equal to the voltage, V divided by the total resistance for the whole circuit, so it's 9 divided by 180, and 9 divided by 180 is 0.05 amps. Put a 0 on the end because we should be working to at least 2 significant figures. Next part, calculate the voltage reading on the voltmeter. Well, the voltmeter is reading the voltage across one of the resistors. We know the value of that resistance, it's 60 ohms, and we know the current flowing through that resistor because the current in that resistor is the current in the whole circuit, which is 0.05 amps. So therefore, the voltage we're trying to find is the current times the resistance there, R2, so it's 0.050 times 60, which is 3 volts. So for question 3, for the first part, calculate the total resistance of the circuit. And it does say don't attempt to do it all in one stage. Quite a lot of people did try and do it in one stage and got all sorts of mix-ups. Even though they got the right answers, they ended up writing things that simply weren't true, or that didn't say what they thought it said. So it's much better to be methodical. So first thing we're going to do is we've got 3 resistors in parallel. So let's work out the total of those. And it's useful to tell the person who's reading your work what you're doing. So if I just make a note, for the 3 parallel resistors, and I want to have a name for that resistance of those 3, so I'm going to call it RP. Well, the formula for parallel resistors, of course, is 1 over R, but I'm calling it RP, so 1 over RP is 1 over R1 plus 1 over R2 plus 1 over R3, which is 1 over 40 plus 1 over 20 plus 1 over 40. That's 1 over 40 plus 2 over 40 plus another 1 over 40, it's 4 over 40. So it's 1 over RP equals 4 over 40. And for goodness sake, avoid the temptation to just put equals 40 over 4, because it doesn't. 4 over 40 doesn't equal 40 over 4. We've got to remember that that tells us that RP must equal 40 over 4, which is 10 ohms. But the question said the total resistance. So total resistance, and you can tell that I'm writing down the total resistance because I've written total resistance. Don't be scared to put words to make things simple. Total resistance must equal that parallel resistance plus the 50. Don't need to bother putting letters in, it's just I'm going to be honest what I do. It's the 10 we've calculated plus the 50 that's over there equals 60 ohms. Right, the last part, a lot of people went wrong here. Calculate the current through the 50 ohm resistor. Everybody knew that there's 12 volts in the circuit, but a lot of people were trying to use I equals V over R, which is the right formula to use. Trouble is, because the question was about the 50 ohm resistor, they took the 12 volts and they divided by 50 ohms, but that isn't true. The 12 volts isn't only pushing current through the 50 ohms, the 12 volts is pushing current through the whole circuit, which is 60 ohms. And the current through the whole circuit all goes through the 50 ohm resistor. So if we calculate how much current the battery is pushing through the whole lot, it's also the current through the 50 ohm resistor. So we do the voltage, which is 12, divided by, not by 50, but by 60, by the whole resistance of the circuit. And 12 divided by 60 equals 0.20 amps. It does matter that you put the 20, because we shouldn't just work to one significant figure, we should work to 2.